In an earlier videotape, we discussed solving fractional equations. We will now revisit this topic, but this time we'll consider some more complicated examples. For example, let's try to solve this fractional equation for x. 5 over x minus 1 over 3 is equal to 4 over x. What distinguishes the examples in this videotape from the ones that we considered earlier is that in these problems, there are variables present in the denominators of the fractions. Okay, now our procedure is going to be the same as before. We're going to look for the lowest common denominator. In this particular case, it's 3x. Okay, and we're going to multiply both sides of the equation by 3x in an effort to eliminate fractions. In other words, we're going to get rid of the fractions in the fractional equation, then we'll solve the equation as we always solve equations. Okay, this is our original equation. We will multiply both sides of the original equation by 3x. Okay, now we're going to distribute the 3x through here. We have 3x times 5 over x. Take away 3x times 1 over 3 is equal to 4 over x times 3x. Okay, now in the first term here, the x's cancel out, and we get 3 times 5, or 15. In the second term, we have minus. Now the 3's cancel out. Minus x equals, over here, the x's cancel out. We get 4 times 3 equals 12. To solve this equation, we would like to isolate x, so we'll subtract 15 from both sides, giving us minus x equals minus 3. And then multiplying or dividing both sides of this equation by minus 1 to get x alone. Remember, you could think of this as, say, minus 1x. Okay? Dividing both sides by minus 1, we get the final answer, plus x, or x equals plus 3. Okay, now it's very important in a fractional equation to check your answer. Okay, we have x equals 3. We're going to go back to the original equation, which is 5 over x minus 1 over 3 equals 4 over x. And we're going to substitute in the value that we just found, x equals 3, and see if we get a true statement here. Okay, substituting x equals 3, we get 5 over 3 minus 1 over 3 should be equal to 4 over 3. And of course, 5/3 minus 1/3, that equals 4/3. And our check is complete. Always go back to the original equation, not the equation that you get, okay, after you've multiplied through by the LCD, or the lowest common denominator. Go back to the original equation in the problem. Okay, now I just want to point out that there's a difference between solving an equation like this, 5 over x minus 1 over 3 equals 4 over x, or, say, subtracting two fractions. Okay. To begin with, the problems will be stated differently. A problem like this will say, solve for x, or solve the equation. Okay? And you'll have an equation. You'll have an equal sign in the original problem. Over here, it might say subtract the fractions or perform the indicated operations. There is no equal sign. This is not an equation. You cannot start off by multiplying through by the LCD. In this problem here, we multiplied through by the LCD. We multiplied both sides of the equation by 3x. Of course, there were both sides of the equation. You have to have both sides. You have to have an equation with two sides here. You multiply both sides by the LCD, and you get an equivalent equation. Okay? Here, we don't have both sides. We don't have an equal sign. We don't have an equation. You cannot just simply multiply an expression by another value and get an equivalent expression. That doesn't work. If you have an equation, it's okay to clear fractions, to multiply both sides by the lowest common denominator. If you don't have an equation and you have a problem with fractions and you want to, say, subtract these fractions, what you must do is, of course, combine. You have to build fractions equivalent to these fractions using the fundamental principle of fractions. Build fractions equivalent to these fractions having the same denominator. The denominator will be the lowest common denominator we'll try for. And then once these two fractions have the same denominator, we will subtract their numerators and combine over that lowest common denominator. Okay, now over here, if we just wanted to subtract these two fractions, we would try to build fractions equivalent to these fractions that had the same denominator. We already know that the lowest common denominator in this problem is 3x. Okay, so we would like to build fractions equivalent to the original fractions. This time they should have the denominator 3x. Okay, the fundamental principle of fractions says you'll get a fraction equivalent to a given fraction if you multiply the top and the bottom by the same non-zero constant. Okay, now let's look at this fraction 5 over x. In order to get the denominator 3x from the denominator that we had x originally, we would have to multiply the denominator of this fraction by 3. Therefore, we will also multiply the numerator of the fraction by 3. In other words, 5 over x is equivalent to 5 times 3 over x times 3, multiplying the top and the bottom by 3. This gives us a denominator of 3x. Similarly, over here we had a fraction with denominator 3. We would like to build it into a fraction, transform it into a fraction with denominator 3x. We will multiply the denominator by x. Therefore, we must also multiply the numerator by x. Okay, in both cases, we are multiplying numerator and denominator by a non-zero the same non-zero constant. Okay, now don't make a mistake at this point and think that you can simply cancel the x's. Well, you can cancel the x's, but that would get you back to where you started. Okay, we're not trying to reduce to lowest terms at this point. We're building larger fractions. These fractions are not in lowest terms. The important thing is that they now have the same denominator. And we know that if we want to add or subtract fractions, they must first have the same denominator. Okay, since these two have the same denominator, we can combine the numerators. 15 minus 1x, 15 minus x over 3x. Okay, so in this case, we were solving an equation, a fractional equation. We started off with an equal sign, an actual equation. We multiplied through by the lowest common denominator, and we solved for x. This particular problem over here was simply a subtraction of fractions problem. Okay, let's solve this. For x, 2 over x plus 3 plus 1/2 equals 5x plus 11 over 2x plus 6. Okay, we want to find the lowest common denominator, okay, of all these fractions, so we can multiply both sides of this equation by the lowest common denominator, and in doing that we will clear fractions. Okay, in order to find the lowest common denominator, it's important to factor each of the denominators completely. X plus 3 is factored as far as it's going to go, 2. 2x plus 6, however, is 2 times x plus 3. You see, the lowest common denominator is formed by taking each factor the largest number of times it appears in any one denominator. Okay, if you don't recognize that 2x plus 6 is really 2 times x plus 3, and that these factors have really occurred before, you're going to pick a denominator which is not really as small as it could be. Okay, the lowest common denominator in this case is going to be 2 times x plus 3. Okay, the smallest quantity such that each of these denominators divide evenly into it without a remainder. Okay, we will multiply both sides of the original equation by 2 times x plus 3. Okay, and we can distribute at the same time. Okay, so we're going to have 2 times x plus 3 times 2 over x plus 3 plus 2 times x plus 3 times 1/2 equals 5x plus 11 over 2 times x plus 3 times 2 times x plus 3. We are multiplying both sides of the equation by 2 times x plus 3, which means we multiply through all the terms by 2 times x plus 3. This gets multiplied by 2 times x plus 3, this, and also the right side here. Okay, let's see what happens. When you multiply the first term here by 2 times x plus 3, the x plus 3's cancel, and we just get 4. Now when you multiply the second term by the 2 times x plus 3, the 2's cancel, leaving you with just the x plus 3, equals, when you multiply the right side by 2 times x plus 3, the 2 times x plus 3 cancels out, leaving you with just 5x plus 11. Okay, now let's see what we have on the left side. We have 4 plus x plus 3, that is x plus 7, equals 5x plus 11. We want to solve this equation for x. We're going to isolate x on one side of the equation. Let's subtract x from both sides, giving us 7. Here the x is, x minus x gives you 0. 7 equals 5x minus x, which is 4x plus 11. Let me continue that up here. We have 7 equals 4x plus 11. We will subtract now 11 from both sides of the equation. 7 take away 11 is minus 4 equals 4x. Dividing both sides of the equation by 4 to get x alone. Minus 4 over plus 4 is minus 1. 4x over 4 is just x. So we have our answer. X equals minus 1. And now we'll proceed to our check. We go back to our original equation. You'll remember that's 2 over x plus 3 plus 1/2 equals 5x plus 11 over 2x plus 6. You must go back to the original equation. After you could make a mistake at any point after this, and you want to go back to the original equation to check your answer. X equals minus 1 is our answer that we would like to check. We get 2 over minus 1 plus 3 plus 1/2 should be equal to 5 times minus 1 plus 11 over 2 times minus 1 plus 6. Okay, minus 1 plus 3 will give us 2. This is 2 over 2 plus 1 over 2 should be equal to, now we have minus 5 plus 11 minus 2 plus 6. 2 halves plus 1/2. On the left side, we have 3 halves. This should be equal to minus 5 plus 11 gives you 6. Minus 2 plus 6 gives you 4. And of course, 6/4 can be reduced to 3 halves by dividing numerator and denominator by 2. So we get 3 halves equals 3 halves, and that works out. A common mistake in working through a check like this is that people think that they can, say, multiply both sides by whatever denominator they want and work it through that way. Remember, we're not sure at the moment that these two things are equal. Okay, you work with the left side separately. You work with the right side separately. And then we hope that the two, the left side and the right side will eventually turn out to be the same value. That will prove that our check, that will finish our check and prove that our value is correct. Just work with the left side separately and the right side separately. If you want, you can draw a line right down the middle. Okay? Do not work on both sides, only one side at a time. Okay, so we have finished that problem. Three over x minus 2 plus 1 equals 3 over x minus 2. Now, the lowest common denominator is x minus 2. This 1 can be thought of as 1 over 1. Okay, so it has a denominator of 1 there also. The lowest common denominator is x minus 2. We will multiply both sides of this equation by x minus 2. Multiply both sides of the equation by x minus 2. On the left side, we're going to have to distribute the x minus 2 through the parentheses. X minus 2 times 3 over x minus 2. The x minus 2's cancel, and you get 3 plus now x minus 2 times 1. 1 times x minus 2 is just x minus 2 equals 3 over x minus 2 times x minus 2. The x minus 2's cancel. You just get 3. Okay, don't make the mistake, okay, if you don't actually, say, rewrite the problem and distribute the x minus 2 on the paper, don't make the mistake of, say, canceling out the x minus 2 here and then thinking that you don't have anything to multiply by the 1. Okay, you don't actually do the canceling out on the paper and make this disappear. You say this is going to be multiplied by this, and then it'll be multiplied by that. Okay, let's see what we have. We have x minus 2 plus 3. Okay, x plus 1 equals 3. Subtracting 1 from both sides, okay, we get x equals 2. Okay, now we check this answer in the original equation, which was, of course, 3 over x minus 2 plus 1 equals 3 over x minus 2. And let's see what happens. We plug in x equals 2. We get 3 over 2 minus 2 plus 1 should be equal to 3 over 2 minus 2. And we look at what we've written. We've written nonsense because 2 minus 2, of course, is 0. 3 over 0 doesn't make any sense in our mathematics. So we obviously have got a problem over here. Okay, we seem to have followed all the steps through logically. We get an answer, and it doesn't check. It doesn't check. It doesn't even make any sense. Okay, now, this can sometimes happen in a fractional equation, which means that the check in such a problem is very, very important. Okay, I'm talking about the fractional equations that involve variables in the denominator. Okay, if they just had constants in the denominator, you don't have to worry. Then you're checking just to make sure you haven't made any arithmetic mistakes. But if you have variables in the denominator, you can follow all these steps through logically and wind up with an answer that doesn't make any sense whatsoever. Okay, now let's see where we went wrong here. Well, over here in the original problem, okay, x couldn't be equal to 2, because if x was equal to 2, the original equation didn't make any sense at all. Okay, now, let's say you didn't notice that to begin with. You work through all the steps, you get the answer x equals 2. The check will tell you that you've made a mistake. Now, where was the mistake? The problem is that when you multiplied both sides of the equation by the lowest common denominator, x minus 2, we were assuming, actually, that x minus 2, the lowest common denominator, was not equal to 0. See, when you take an equation, you can take a false equation, multiply both sides by 0, and you blow the distinction between true and false. If I start off with, say, 4 equals 7, which, of course, is not true, if you multiply both sides by 0, 4 times 0, 7 times 0, you get 0 equals 0, which is true. So multiplying by 0 is a very dangerous thing to do. Even though 4 is not equal to 7, when you multiply both sides by 0, you get a true statement. Okay, so multiplying by 0 can, okay, cause us to lose the distinction between a false equation and a true equation. Multiplying by 0 results always in a true equation. See, it turns out this original equation is not true for any x values whatsoever. Okay, when we multiply, there were no x values that made this a true statement. When we multiply by x minus 2, which in this case was 0, we lost that property. Now, we've worked through all the steps. You don't have to worry about this when you start a problem. I mean, you might notice it in the beginning. For example, you say, look, if x is equal to 2, I have division by 0, which is no good. So should I get an answer of x equals 2, I'm not going to accept that answer. But even if you're not that clever, you just proceed as usual. You find the lowest common denominator, you multiply both sides by the lowest common denominator, you get an answer, and you go to check it. If you get something silly involving division by 0, that means that you have inadvertently, say, multiplied both sides by 0, okay, which is what you don't want to do. You'll have a tip-off. The check will involve division by 0, okay, and you'll know you've made a mistake. You then go back and say, no solution to this problem. So the only possible answer, we've worked it all through, the only possible answer was x equals 2, and that's not the answer. Therefore, there is no answer to this particular problem. Okay, now sometimes when you have to check a fractional equation, the check gets horrendous. The fractions get very confusing, and it's sort of hard to work all the way through. Okay, you don't have to go all the way through. What you really have to do, I mean, it's nice if you go all the way through, that'll make sure your arithmetic is correct. But if you don't have the time or the patience to go all the way through, at least go through the first step. The first step will be your tip-off, okay, whether or not you've run into this kind of problem. If your first step here doesn't give you the division by 0, and if you want to continue with the proof just to make sure your arithmetic is fine, that's okay. But if your first step gives you division by 0, that means that this answer is incorrect. Okay, so it's very important to at least go through the first step of a check on a fractional equation to make sure you're not going to get any division by 0. Okay, and the answer to this problem, there is no value of x that makes this a true statement. There is no solution to this equation. (12 over x plus 3 minus 2 over x equals 4 over x squared plus 3x. Once again, we want to factor all our denominators completely. This denominator over here factors into x times x plus 3. Our lowest common denominator is x times x plus 3. We now multiply both sides of this equation through by x times x plus 3. Okay, we can multiply each term by x times x plus 3. Okay, x times x plus 3 times 12 over x plus 3. Take away x times x plus 3 times 2 over x equals 4 over x times x plus 3 times x plus 3. So we've multiplied each term by x times x plus 3, the lowest common denominator. This will clear fractions for us. Okay, in the first term, the x plus 3 is canceled, leaving us with just 12x. Take away. Now, on the second term here, the x's cancel, leaving us with 2 times x plus 3. And on the other side of the equal signs, the x and the x plus 3 cancel, leaving us with just 4. Okay, 12x. Now, sending the minus 2 through the parentheses, we get minus 2 times plus x, that's minus 2x. Minus 2 times plus 3, that's minus 6, equals 4. Don't forget to distribute the minus 2 through the parentheses. Okay, combining like terms, 12x minus 2x gives us 10x. Minus 6 equals 4. Adding 6 to both sides. Okay, gives us 10x equals 10. Okay, you'll see you add 6 here, you get 0. So you have 10x equals 4 plus 6, which is 10. Dividing both sides by 10, x equals 1. Okay, is the only possible answer, and we have to check to make sure it really is the answer to this problem. Going back to the original equation, which was 12 over x plus 3 minus 2 over x equals 4 over x squared plus 3x. Substituting in x equals 1, we get 12 over 1 plus 3 minus 2 over 1 should be equal to 4 over 1 squared plus 3 times 1. 12 over 4 minus 2 should be equal to 4. Now this is 1 plus 3. That's 4, 4 over 4. 12 over 4, that's 3, minus 2 should be equal to 1. And of course, 1 equals 1. Okay, so our answer x equals 1 is in fact correct. This brings us to the end of the videotape. If you have any questions, you can view the videotape again or consult with a tutor in the math lab.